This chapter is titled Polynomials, and it's essentially working with polynomials, products, and factors. So what we're going to be doing is multiplying and dividing with polynomials. So first off, what's a polynomial? So poly, many, and a nomial is number. So a polynomial means exactly that. Now we have some components, and you're already familiar with this. Let's say we had three x, y, z. That's a coefficient, which is the number in the front. Of course, these three are variables, and that's part of algebra. Algebra introduces the concept of variables. Now, we understand that there's another concept here, and we understand that unless you see it, the exponent is 1. So we understand that the exponents here are all 1. So we could change that up and say this is 2, this is 2, and this is 3. The degree of a polynomial equation references the highest exponent. So this is a third degree expression polynomial. There are other definitions that I would encourage you to read on the on page 167, and I would really encourage you to read those just in case anywhere on a standardized test or any exam or a future course that you run up against any of these definitions and you are unclear about them. But in the section 1 here, 4.1, what we really want to do, and it's largely review, I think, with you all, is combining similar monomials, combining similar polynomials, because we've got to walk before we can run. And before we get to do more complex maneuvering in this chapter, we want to make sure that you can add and subtract. So if you look on 169 and 170, there are plenty of oral exercises, and of course on 170 there are there's of course written exercises. I recommend that you do any of the A and B problems, that's 1 through 24. So I'm going to turn a page here and do a couple for you. So I'm going to clean my board here and grab a color, and then we'll do a couple. So here is a problem on page 170. So I want to start off with a simpler problem, but I want to make sure that everybody knows how to do this. The directions are to take this first term and the second term here, which are polynomial expressions. This is a second degree, so is this second. And the directions are to first add these together and then subtract. So what I want to emphasize here, and again, I'm pretty much assuming that you know how to do this. If we add these two, then we're going to look for like terms. So in doing these, I often suggest that you check these off. We look at t squared and t squared, and if we add these two, how many quantities of t squared do we have? Well, of course, we have 2 t squareds. Looking next downward, now we do agree in mathematics to write polynomial expressions in terms of descending order of degree of equation. So we are going to write the descending order. So this is understood to be t to the 1, and this is t to the 1. So we have a negative 8t plus a positive 5t, which results in a minus 3t. So those are done. And now we're left with a negative 7 plus a negative 6, which is, of course, minus 13. That is as far as we can go with this. We can no longer simplify that or combine terms on this. Now, this is another problem. This is number 19 on the same page, 170. This is a little bit more complicated, and I don't think it's complex. It's more complicated because we are going to add in the distribution property here. So in front of these parentheses, we have a coefficient. So we can have a coefficient in front of parentheses here. Doing these operations, then we will need to combine like terms. So in doing this, we look at this and we have 2 times 4m squared, which means we have 8m squared. And this distribution here, we have 2 times a positive 3, which is plus 6. Now this is where often students make mistakes, and it's a hard thing to understand that this entire quantity inside these parentheses are being multiplied by negative 7. There's a negative in front of this. So a negative 7 times 1m squared is minus 7m squared. And a negative 7 times a negative 2, a negative times a negative is a positive, so this is positive 14. Now, in doing this, we have now cleared these parentheses, to which now we're going to add 1. Now, very similar to what we did up here, now we combine like terms in descending order of degree of equation. So look at the first ones here. We have second degree and second degree. Now we have 8, positive 8m squared plus a negative 7m squared. So that results in 1m squared, and we traditionally do not write that. So those are done. Check them off. And now we have 6 positive plus 14 positive, which is 20 plus 1. So we have m squared plus 21. And that is our final simplified answer to this polynomial addition. Now that's all we're going to do in this section. I'm going to make a different video so that these are nice and short and sweet. I'm going to make another video on section 4.2, the laws of exponents, so you can advance to that if you'd like.